Hello, everyone. Today we begin a fascinating chapter called A Square and a Cube. Today we are going to explore something very interesting, squares and cubes of numbers. Have you ever wondered why numbers like 4, 9, 16, and 25 appear so often in mathematics? In your textbook, there is a famous story about Queen Ratnamandri. She left a puzzle for her son involving 100 lockers and 100 people opening and closing them in a specific pattern. In the end, only a few specific lockers remain open. Spoiler alert, the lockers that stay open are all related to these special numbers. Let's find out why. So, what exactly is a square number? A square number is obtained by multiplying a number by itself. For example, if we take the number 3 and multiply it by 3, we get 9. If we take 5 and multiply it by 5, we get 25. We write this as 3 with a power of 2 and 5 with a power of 2. We read this as 3 squared or 5 squared. When a natural number is squared, the result is called a perfect square. But why do we use the word square? Imagine you are planting a square garden. You want 4 rows of plants and 4 columns of plants. The total number of plants is 4 multiplied by 4, which equals 16. Because the plants form a perfect geometric square on the ground, 16 is called a square number. It is directly tied to how we measure area. Now that we know about squares, what about cube numbers? A cube number is obtained when a number is multiplied by itself 3 times. For example, 2 into 2 into 2 equals 8, or 3 into 3 into 3 equals 27. We write this as 2 with a power of 3, or 3 with a power of 3, and we read it as 2 cubed or 3 cubed. To visualize this, imagine a large 3D cube made of smaller boxes. If each side is 3 boxes long, 3 boxes wide, and 3 boxes high, the total number of small boxes is 3 times 3 times 3, which is 27. While squares help us measure flat area, cubes help us measure 3-dimensional volume. Did you notice something interesting? Square numbers grow like this: 1, 4, 9, 16, 25. All perfect squares will always end with the digits 0, 1, 4, 5, 6, or 9. They never end in 2, 3, 7, or 8. Meanwhile, cube numbers grow much faster: 1, 8, 27, 64, and 125. Squares and cubes are very important. They aren't just for puzzle. They help us understand area, volume, algebra, geometry, and many advanced science topics you'll encounter in the future. They are the building blocks of mathematics. Now that we understand square numbers, let's explore square roots. Imagine a square with an area of 49 square centimeters. What could be the length of each side? Since 7 into 7 is 49, the side length must be 7. So we say 7 is the square root of 49. In general, if a number x into x equal to y, then x is called the square root of y. For example, 8 into 8 is 64, so the square root of 64 is 8. But here is something interesting. Minus 8 into minus 8 is also 64. So every perfect square actually has 2 square roots, one positive and one negative. However, in most school problems, we usually take the positive square root. Let's see how we check whether a number is a perfect square. A perfect square can be written as a number multiplied by itself. For example, 324 equals 2 into 2 into 3 into 3 into 3 into 3. We can group these factors into pairs: 2 into 3 into 3 into 2 into 3 into 3. That means 324 equals 18 squared. So the square root of 324 is 18. But if the factors cannot be paired, the number is not a perfect square. Now let's move to cube roots. You already know that a cube number is formed when a number is multiplied 3 times by itself. For example, 2 into 2 into 2 equals 8. So 8 is a cube number. Since 2 cubed is 8, we say 2 is the cube root of 8. Similarly, 3 into 3 into 3 equals 27. So the cube root of 27 is 3. In general, x into x into x is y. Then x is called the cube root of y. How do we know if a number is a perfect cube? We use prime factorization. Take the number 3,375. 3,375 equals 3 into 3 into 3 into 5 into 5 into 5. We can group the factors into triplets. 3 times 5 times 3 times 5 times 3 times 5. So 3,375 equals 15 cubed. That means the cube root of 3,375 is 15. If the prime factors cannot form groups of 3, then the number is not a perfect cube. Before our class, here are a few puzzles for you. First, is 50 a perfect square? Second, can you find a number whose square is 144?